Hello everyone, thanks for joining. My name is Ohad and I will speak about Xennet today. And let me begin with some background. Well, you know that the world of distributed computing is gaining a huge acceleration over the recent years. Even before that, if we recall World Community Grid, which is the most known and successful project for cloud computing, which began about 15 years ago and serves many interesting projects in science, in medicine, and so on. And it is based on people donating their computational power. And they have, say, about 100,000 nodes. And they managed to make, to reach very nice results in science since then. Now the point is that they donate their computation. They don't get nothing. That's one point. The second point is that it's closed. It's semi-closed, say this. If I want to fold my protein on their system, it's not very easy to get in there. If indeed I want to fold, say, many proteins, and I really need massive computational power, then I will. My option is go to something like Amazon Web Services, AWS, or any other hosting provider. But the problem is that it's pricey. The second problem is that it's closed again, but from the other direction. Only they rent their own hardware. I cannot monetize my own computer like home computers are being utilized in World Community Grid. Now, this goal to utilize all home PCs with some incentive was deeply thought over the recent years, and there were many problems that couldn't be solved because of the lack of advances in science, in engineering. Now, since 2009, we have the blockchain technology, which gives us the power of decentralization. So putting the three of those together, Amazon Web Services and World Community Grid and blockchain technology, gives us Xennet. On Xennet, anyone can put their computer to rent, anyone can rent as much as they want, and the system is fully decentralized, no central entity of any kind, just like even Satoshi Nakamoto can't have any influence on Bitcoin. Now, the main concerns about such a system is, of course, let me write down concerns. We have, of course, the concern of trust, the concern of security, the concern of fairness, and we will touch more concerns later on. Let me quickly describe the flow of the system, the main flow, or let me begin with terminology. We have basically two kinds of entities, the one who needs computational power and the one that gives computational power. With the first one we call a publisher. We call them publishers or bidders. And those people, naturally home computers, we call providers. let me just a sec adjust this display. Okay. So what connects publishers to providers is some central database which cannot be tampered unless you have, say, most of the network, just like in Bitcoin. On the blockchain, the publishers, that's why they call publishers, they publish an announcement that they need computational power. The providers fall on the blockchain, and when they see a job that may feed their computer, they directly connect to the publishers. That's a very important point. From now on, the blockchain is off until the end of the process where the provider redeems the money, the coins he deserves. But the computation and the negotiation is done directly between those two entities with no middleman and no influence, no information on the other network at all, on the rest of the network at all. The mechanism of payment between those entities is the micropayments algorithm. Since we want the accounting to be every few seconds, every very short period of time, to reduce the risk, of course. So how can we do this efficiently? How can we transfer value every few seconds without friction? This problem has been solved already, and it appears on the wiki of Bitcoin. And basically, what happens is that if we call this A, we call this B, basically what's happening is A deposits some cash on a multi-sig address that needs the signatures of both and AB to release this money. Only when this transaction gets confirmed, then we can pass on. And here we touch the common question, why won't Zennet use Bitcoin? Because if we use Bitcoin, until the computation will begin, we will have to wait too long time. After the money has locked, let's say just beforehand, B has to send to a refund transaction, that if B runs away and the money is still locked, after a certain time, A can redeem the money. Now this redeem transaction is constantly updated. It's of course not being broadcast, it's still off chain. A got the signed transaction and they can broadcast it whenever they want. I'm sorry for my English. Now every few seconds what happens is that A sends to B a transaction which the amount of redeem and the amount of payment change accordingly to the desired pricing. Now, how will they set the price? Well, I will get into this point. It's a big deep point. Let me just present the problem. How can we measure the consumption of resources? There are many resources, many kinds of resources. We have CPU, RAM, and so on. Well, how regular hosting providers do the pricing? They just charge you according to time. No matter how much from the resources you have consumed. And this is, of course, not very fair, because you always pay more. And you cannot split one PC into two providers, since they have to guarantee them the amount of resources that is always available to them. So we got many types of consumption, say and so on. Now, I could just naively set a price for each of them and charge according to this, but it's basically a fiction, because no such a thing, pure CPU without RAM and so on. So the main underlying variables we want to price are known. So let's call these measurements, denoted by M, and we have the unknown variables. Now, since the unknown variables are atomic, and they're also cumulative, how do I know that if they are known? Well, that's what I require them to be in order to measure consumption. Now, atomic and cumulative variables behave linearly, so we see a linear connection between the variables we measure and the real consumption. Now, if I have a program, say call it P, because several programs, P1, P2, P3, and I know the program as a whole, how much I will take for it. For example, we are talking about closed jobs only, 1,000 additions, multiplications of the same numbers. If the provider tell, I want for this job, say 1 Zen coin, for example, for this 2, for this 3, so I know that between those two, say there is a matrix, call it A, then I can tell that those prices, if we denote them by P, we know that MA equals VP. That's very roughly and very not exact, see the PDF for more information, but the main point is that the provider just have to set a price for a whole consumption of their computer. Then we run some closed tasks in order to measure the performance, in order to translate those prices into those components, and then we can ongoing know how much weight they require for each. This becomes feasible only because we speak about distributed tasks, and that's a very important point. That's the main assumption of Xennet. But I don't even say only massive, since sometimes there are bursts in performance. For example, one I/O request that may be stuck or something, and this may be very important on standalone machines, but on massive distributed computings, we just have a lot of jobs, a lot of little jobs, and we have to distribute it between many computers, and we don't care if one computer did 1,000 jobs a second, or 1 job a second. They will pay according to the number of jobs. We don't care for I/O bursts, for example. So this assumption makes this whole model valid and makes Xennet be able to be fair. There are some more consequences of this assumption. We will get to this, I hope, later. Okay, so what's after? So we say that the publisher publishes an announcement, then the provider connects to them, then they agree on a price, they initiate the micropayment protocol, and then what's happened that the provider creates a Docker container. This Docker container is dedicated for the publisher. let me tell some about Docker. The first gen of virtualization is what you know, what's known as VMware or VirtualBox. That's emulating a whole computer. That's what you get basically on Amazon. They emulate you a whole computer, but this is very not economical, because you have to duplicate a whole emulation of computer and kernel and everything to each user, while they all can share the same resources. That's where Docker comes to place. Docker is so-called, it's second gen virtualization, and so-called OS virtualization. Docker splits only the user space. We have one kernel, and it splits to different user spaces. Each one is separated. They cannot see each other thanks to a feature of the Linux kernel called control groups, or for short C groups. And measurements can show that Docker brings about 30% more efficiency than running a lot of hypervisors. So, the publisher connects, the provider initiates a new container for them, but this all happens inside an hypervisor. Well, it doesn't must be, but for the convenience and the security of the user, what happens is that you have a hypervisor. It runs an operating system that will be called Zennet OS, which will run Docker. Now, if one doesn't has a computer dedicated for Xennet, they can just install Zennet OS on bare metals and skip the hypervisor step. But what happens here is, and this touches a concern of security to the home PCs, that malicious publishers won't be able to harm their computer to get into their documents and so on. So hypervisor is a pretty proven secure technology. Everyone uses it, Amazon and everyone. Now that's only one layer. The second layer is Docker. Docker is also secure. Well, there are vulnerabilities of Docker, but they happen, as far as I know, only if you are a root user, a privileged user. That's why we give the publisher only unprivileged user. Hence you have 3 layers of protection against breaking the sandbox. Okay, so they now all run inside their Docker containers. They run whatever they want. That's a very important feature of Xennet, that you can just run anything. You get an operating system, and you can run native code and anything. Now, every few seconds, as I said before, they are all, by the way, Linux containers. On Linux, you have the so-called RACFS, which is a virtual operating system that's being supplied by the kernel to show consumption measurements of many variables. And every few seconds, we read those variables. No, I've deleted them already. We read the CPU, consumption, RAM consumption, and so on. And the provider has either to pay, or they can disconnect if they think they are being cheated. Either way, the loss is very small, because computing resources rented for a few seconds is by all means negligible. Okay, let's move on. You can check the IRC if there are questions. Please ask before I go on. Okay, no questions so far. Please ask if something is unclear or you want me to touch a certain point. Okay, so let's speak about the concerns we wrote before. As for trust, first we cannot have a public database of reputation because someone can fake the reputation. They can generate as much addresses as they want and give ourselves a high reputation. So first, you have trusted entities, such as universities or data centers. They can publish on their website their address on Zennet, and whoever wants to count on them is able to trust them, and there's no question of trust. Now, of course, the main goal is to work with untrusted publishers. There is also the local history. You can know from your own experience who cheated you and who didn't. Of course, they can always create a new address. That's why we speak about ID proof of work. The address is, of course, just like Bitcoin. It's a garbled long string. And if I want an address to begin with, say, many zeros, I have to invest computational power, just like in mining. So I can tell that I work only with entities that have a certain amount of zeros. They have to work for it. And this way I can avoid spammers. They cannot create a new address difficult enough every short period of time. Now there is another point. I'm also touching security, replication. That's basically what World Community Grid is doing. They just say compute the same task twice. If you compute the same task twice, you invest twice coins, but your risk decreases quadratically. So the linear increase at the cost gives exponential decrease at the risk. Another description we have here. Say that each provider serves 10 publishers concurrently. This way we just decrease we cut the risk tenfold to both sides. And at the scope of distributed tasks, this is of course very acceptable. We can also we can throw the ineffective providers. Say, after a few seconds, if a publisher hired, say, 10,000 computers, they can just forget, throw the less performing 5,000 ones, and nothing happens, and they can just continue working, and the loss isn't high. we also there are new algorithms of verifiable computing where you can prove in cryptographic way that the computation was correct. The problem is that those methods are very costly in terms of performance, say thousands or tens of thousands slower. But thanks to Hunter Miner Crafter, which you can see on Bitcoin Talk on our thread, he proposed a new algorithm that can give us verifiable computing for affordable costs. I see there's a question. Let me read it. Okay, I see a question about providers performing DDoS, distributed denial of service attack. Well, if I got the question correctly, this can be fixed by either trusted entities, of course, and by requiring ID proof of work. Of course, a publisher is the entity that has a lot of money. They have, well, not necessarily, but in terms of small computations, even a few dollars is a lot of money, because cheating won't give much, each single cheat. So they can be blocked very fast. And if I require proof of work, I can know that they don't generate a new address any second. Let me see the other question. Yes, the proc-first variables aren't enough, and I pointed to this when I talked about unknown variables. I think it's a bit out of scope, but please read the PDF I wrote. Maybe I will do a dedicated movie for this to explain this algorithm. Next question. Yes, about Docker, what other advantages it has other than security? Well, as I say, it gives you about 30% more performance, since you don't have to split the emulation of a computer. You don't have to split the kernel. They all share the same kernel. So it gives a huge increase in performance. Also, it's very easy to move Docker containers between computers. It's only a year and a half old product, but gained a lot of respect, and it is indeed a great product. Okay, any more questions? I think I skimmed the whole system till now. Well, no further questions. Okay, so I guess we're finished. Thank you very much, everyone.